This is 8051 microcontroller. As soon as we switch on the power button, 8051 should display minus SDA51. This, if it is not coming, we can use a button called as reset button and we can see the display. In this 8051 controller, the main important knobs are reset knob, previous, next, go, substitute memory, execution. These are the main blocks for a simple program. Other than this, these are the buttons which are having hexadecimal numbers starting from 0, 1, 2, 3 up to 9. After 9, A, B, C, like that up to F. A means 10, B 11, C 12, similarly F will be 15. Today I am going to show you how to execute a simple program using 8051 microcontroller. In this session, I will show you addition of two numbers where the numbers are stored in the memory location 9000. This microcontroller user memory location starts from 8000H. So I am showing you the program from 8000H, how to execute the program. Before that, let us have a look of this 8051 simple program. Have a closed look of this 8051 microcontroller addition program. A brief explanation. This field is called as memory location, where the opcodes and operands are stored. This is a label part. We use it when we call subroutine. This is mnemonics, which is nothing but the program sequence. Mnemonics are followed by operands in some of the instructions. Comment, this tells us what these instructions are meant for. For addition, we are storing the data in 9000 and 9001. After the program is done, after the execution is done, the result is stored automatically in 9002H. H here denotes these are hexadecimal numbers. So right now the data 1 is in 9000, data 2 is in 9001. We are using the first instruction, move 9000, a 16-bit memory address, to a data pointer. Data pointer is a 16-bit register. Now the next instruction is move X at the rate of DPTR to A. That means move the content of the memory location which is stored in DPTR to A. This is an external memory location, that is why we are using X symbol here. Next instruction, move the content of accumulator to R0 register. By doing these three instructions, we got one data which is stored in accumulator. Next, increment DPTR. It automatically increments the content of DPTR from 9000 to 9001. Now, after this increment, move X A at DPTR. That means the content of DPTR should be stored to accumulator. That is, now the first data is in R0, second data is in accumulator. The next instruction is add R0 content with A content. Increment DPTR. Any operation, the result is always stored in accumulator. After incrementing the DPTR, we need to move the content of accumulator to this DPTR memory which has been specified by this DPTR. That is, we have already incremented second time. Now the DPTR is showing a memory location 9002. To that memory address, the content of A, that means the result, will be stored. Here SJMP is a short jump instruction which is used here, but today what I am showing is an instruction which is called as LCall, long call subroutine. So this mnemonics will be changed according to the instruction. Each microcontroller will stop at the end. The end instruction will be different. In this kit what I am using, I need to use LCall instruction rather than SJMP instruction. You can see in this column opcodes and operands are written. Move DPTR, hash 9000 is a 3-byte instruction wherein move DPTR opcode is 90 followed by 9000, which is this address. This is a 1-byte instruction, E0, F8. Like this we have to write the opcodes and operands using the instruction sets of 8051 microcontroller. Each opcode may be different for different microcontroller. So before we perform, we should check the opcodes of that particular microcontroller only. So today I'll show you a simple program, how to start, how to enter the program, how to execute the program, how to store the data, how to check the result. That is 4 steps. First step, how to enter the program. Now, to enter the program, we need to first press reset, next substitute memory. You can see when I press substitute memory, the field becomes blank. Next 0. You can see a decimal point is displayed on this board which differentiate the address field which is 16-bit and the data field which is 8-bit. Now, after pressing 0, I need to press 8000. While entering, if I make a wrong entry, nothing to worry, I can retype the required value because this arc acts as a shift register. Once I get to know entered the required memory location, I need to press next. When I press next, the data field will be opened. I can type here the opcodes which I showed earlier in the program. So I'll tell the sequence once again. Reset, substitute memory, 0, the starting address of the program, next, and I'll tell the instructions once again. Reset, substitute memory, 0. When I press 0, there's a difference between address field and data field. After this, starting address of the memory location, then next. The first opcode is 90. After this, next, second operand is 90. Next 00, next E0, next F8, next A3, next E0, next 28, next A3, next F0, next 212, next 00, next 03. This is the last instruction. After entering the last opcode, I need to press next twice. That means the first step is completed. I have entered the program. Second step is to enter the data. The data should be entered in the following same process, that is reset, substitute memory 0. Now instead of the starting address of the program, I need to enter the starting address of the data memory location, that is 9000. Next, I need to apply or enter the second data, the datas. I will enter the data 1F. Next, that is the second data field, I will enter 5E. When I do this, the next part, that is 9002, should contain the result. The result for the present given data is 7D. But you can see the display is D and D. After the execution of the program, automatically 7D should be stored in this. So again, press next twice. Now the second step is completed. That is, I have entered the data. The third step is to execute the program. To do that, reset, go. Where to go? The starting address of the memory location, that is where we started the program. 8000. What should I do? I should execute it. Here I should execute twice. When I did this, you could see at last a minus symbol is displayed on the screen. This indicates that your program is being executed properly. The fourth step is to check the result. What are the steps to check the result? Reset, substitute memory 0, 9000. Next, that is, this is the first data. Second data, could you notice here previously it was DD, now the answer is stored. How do you know this answer is correct? You can check the calculation I have done here. I will show you. 1F can be written as a binary number 0001 F1111. Similarly, 5E 0101 1110. F is 15, E is 14. Now when I add 10 is 0, then 1 is 0, sum is 0, there will be a carry, there are 3 ones, so you will get 1 and again a carry 1. Similarly, if we keep on adding, we get the binary number like this. When we get this, convert this to hexadecimal number. 0111 is 7, 1101 is 13, nothing but D. So the answer is 5D. This itself is displayed in this program. That is how we can perform simple programs using microcontroller. I hope this video will be helpful for the students, those who are beginning 8051 microcontrollers, especially the beginners. Thank you. Keep watching my videos, share, like and subscribe. Please press the notification button so that any new videos will be uploaded. You will get the notification and you can learn electronics through real time. Thank you once again.